Most people think Feastables chocolate bars are just made in some small facility with MrBeast watching over everything. The reality is far more complex and fascinating. Deep in Peru at the Machu Picchu Foods facility, massive industrial machines transform raw cocoa beans into millions of chocolate bars through a precise 16-hour process that most chocolate companies can't match. The scale is staggering, the technology is cutting edge, and the quality controls are more rigorous than you'd expect. Here's exactly how MrBeast's chocolate empire actually operates behind closed doors. Most chocolate companies hide their sourcing practices, but Feastables built their entire operation around transparency that goes far beyond typical industry standards. The chocolate industry has a dark history of exploitative farming practices, with many major brands still struggling to guarantee ethical sourcing across their supply chains. Large manufacturers often work through multiple intermediaries, making it nearly impossible to track where their cocoa actually originates or under what conditions it was produced. While competitors make vague promises about sustainability, Feastables committed to 100% fair trade cocoa and joined Tony's Open Chain, a radical transparency initiative that most companies avoid. This partnership requires open sharing of supplier information and farming practices, creating accountability measures that traditional chocolate companies resist implementing. The child labor monitoring and remediation systems that Feastables uses track individual farming families, creating detailed records that trace each bean back to its exact origin point. Living income reference pricing means farmers receive guaranteed payments above market rates, even when global cocoa prices drop during economic downturns. This approach costs significantly more than conventional sourcing, with fair trade premiums adding substantial expense to every batch of chocolate produced. The price difference can be as much as 40% higher than standard commodity cocoa, but it ensures farmers can invest in proper equipment and sustainable growing practices. The difference between mediocre chocolate and exceptional chocolate comes down to two critical processes that most people have never heard of, but determine everything about taste and texture. Raw cocoa beans arrive at Machu Picchu Foods as hard, bitter seeds that bear little resemblance to chocolate, requiring precise temperature and timing controls to unlock their potential. These beans contain the flavor compounds that will eventually become chocolate, but they remain locked away until the manufacturing process releases them through carefully controlled heat treatment. The roasting process operates within extremely narrow parameters, where a difference of just 10 degrees Fahrenheit can completely alter the final flavor profile of millions of chocolate bars. Roasting temperatures reach between 250 and 300 degrees Fahrenheit, with different bean varieties requiring specific time and heat combinations to develop their unique flavor compounds. Ecuadorian nacional beans need 275 degrees for exactly 18 minutes, while Madagascar Trinitario beans require 285 degrees for 15 minutes to achieve optimal flavor development. The Maillard reaction occurs during roasting, creating hundreds of complex flavor molecules that give chocolate its distinctive taste, but this reaction can easily be ruined by improper temperature control. Temperature sensors monitor the roasting drums every 30 seconds, and operators adjust heat levels based on real-time moisture readings and color changes in the beans. After roasting, the winnowing process separates cocoa nibs from husks using precisely calibrated air currents that must be adjusted based on humidity and bean size variations. Grinding transforms the nibs into cocoa liquor through friction heating, where industrial stone mills generate temperatures that must be carefully monitored to prevent burning. The granite stones rotate at 150 revolutions per minute, creating friction heat that reaches 120 degrees Fahrenheit while breaking down cell walls to release cocoa butter and flavor compounds. Particle size reduction during refining brings chocolate down to 15 to 25 microns, smaller than the human tongue can detect, requiring multiple passes through roller refiners. The 16-hour conching process that follows refining develops the smooth texture and complex flavor that sets Feastables apart from mass-market chocolate that skips this time-intensive step entirely. These precision-controlled processes create the foundation for the final molding and tempering stages that transform liquid chocolate into solid bars. Creating a chocolate bar that snaps cleanly and melts smoothly requires manipulating cocoa butter at the molecular level through a process so precise that a single degree of temperature variation can ruin an entire batch. Cocoa butter can crystallize in 6 different forms, but only one produces the glossy appearance and satisfying snap that consumers expect from premium chocolate. Forms I through 4 create unstable crystals that result in grey bloom and poor texture, while Form 6 produces overly hard chocolate that's difficult to bite. The tempering process must heat chocolate to exactly 115 degrees Fahrenheit, then cool it to 84 degrees, then reheat to 88 degrees, with timing measured in minutes and temperatures controlled within half-degree margins. This three-stage process takes 45 minutes to complete, and operators monitor temperature probes every 15 seconds to catch deviations before they destroy the batch. Form V crystals are the desired crystal structure, creating stable chocolate that resists bloom and maintains its appearance for months, but achieving this requires constant agitation and precise temperature control. Industrial tempering machines use seed crystals and controlled cooling curves to encourage proper crystallization, but the process can fail if ambient factory conditions change unexpectedly. The machines add pre-tempered chocolate containing Form V crystals to encourage proper structure throughout the batch. Humidity levels above 50% can interfere with crystallization, while temperature fluctuations in the factory can throw off the carefully calibrated cooling process. Molding happens immediately after tempering, with depositors filling molds at specific rates to prevent air bubbles while maintaining the correct crystal structure throughout cooling. The chocolate flows into molds at exactly 88 degrees Fahrenheit and must maintain this temperature until the molds reach the vibration tables. Vibration tables remove trapped air from filled molds, but too much vibration can break the crystal structure that was carefully established during tempering. Cooling tunnels maintain exact temperature gradients that allow chocolate to solidify without thermal shock, which would create internal stresses and surface defects. The tunnels cool chocolate from 88 degrees to 60 degrees over 20 minutes, with each zone precisely controlled to prevent rapid temperature changes. Quality control systems use inline cameras and checkweighers to identify bars with improper crystal structure, ensuring only perfectly tempered chocolate reaches consumers. Behind every identical Feastables bar lies a manufacturing system so sophisticated that it can detect defects invisible to the human eye while producing thousands of bars per hour with mechanical precision. The packaging line represents the final stage where months of careful sourcing and precise processing either succeed or fail, with quality control systems that reject bars for flaws most people would never notice. A single scratch on the wrapper surface or a weight variance of half a gram triggers automatic rejection systems. High-speed packaging equipment must handle delicate chocolate bars without damaging their crystal structure, while maintaining production rates that can exceed 10,000 bars per hour. Flow wrapping machines seal each bar in protective packaging using heat and pressure that must be calibrated to avoid melting the chocolate while ensuring airtight seals. The sealing bars operate at exactly 280 degrees Fahrenheit for 0.8 seconds, creating hermetic seals that preserve freshness for up to 18 months. Metal detectors scan every bar for contaminants as small as 0.5 millimeters, automatically rejecting any product that could pose a safety risk to consumers. The detection system operates at frequencies between 50 and 1000 kHz, identifying ferrous and non-ferrous metals, stainless steel fragments, and aluminum particles. Checkweighers verify that each bar meets exact weight specifications, with rejected bars recycled back into the production process to minimize waste. Standard bars must weigh between 59.5 and 60.5 grams to pass inspection. Vision systems photograph each wrapped bar to identify packaging defects, misaligned labels, or surface imperfections that could affect shelf appeal. High-resolution cameras capture images at 2000 frames per minute, comparing each bar against reference standards stored in the system database. Cartonization equipment groups bars into shipping boxes with precise counts, while date coding systems print production information that enables complete traceability. Each case contains exactly 24 bars with matching production codes that track the manufacturing date, shift, and specific equipment used. The entire automated system operates under GFSI-aligned food safety standards and OU kosher certification requirements, ensuring consistent quality that meets international distribution demands. This industrial precision transforms the artisanal chocolate making process into a scalable operation capable of satisfying global demand, while maintaining the quality standards that define the Feastables brand. The next time you unwrap a Feastables bar, you're holding the result of a 16-hour manufacturing process that combines ethical sourcing, precision engineering, and automated quality control systems operating at industrial scale. Each bar represents thousands of temperature readings, quality inspections, and molecular transformations that occur between cocoa bean and finished product. This level of manufacturing sophistication explains how a YouTube creator's chocolate brand can compete with century-old companies while maintaining standards that most consumers never see but always taste. The hidden complexity behind every simple chocolate bar reveals the remarkable intersection of food science, industrial automation, and ethical business practices.